Okay, welcome back to this tutorial. Today I would like to talk about VPC, and we want to have an overview of VPC inside an AWS console. So go ahead and log into your AWS console. I'm using a new AWS account for this one called Masood Training, and I've created a user Masood and I've logged in with my user Masood to this console. So it's not a root account. If I go to IAM or IAM and go back here, if you follow up the previous videos, I've already go through all of them and I've created my customized link and my user, my group and roles, and everything is fine right now as expected as the other accounts. So I'm having multiple accounts for testing purposes. So I'm going back to AWS console, and if you scroll down in this AWS services that we have in the home page, in the networking and content and delivery part, we have something called VPC. So I'm going to click on this one to take a look at the VPC console. At the same time, I'm going to open another tab and type AWS VPC and hit enter. So I wanted to create a PowerPoint for this lecture, but I was thinking about the AWS documentation itself, and I was taking a look at the documentation from AWS, and it seems that it's pretty good documentation. So I prefer to take a look at the website instead of just having some PowerPoints, which it's gonna be just copying and pasting these information to the PowerPoint. As you can see in this website, which is the aws.amazon.com/VPC, a VPC, it's the abbreviation of the Virtual Private Cloud, and it's a keyword in AWS that we will use it a lot. So you have to remember this. So Amazon Virtual Private Cloud, or VPC, it's actually a logical isolated section of AWS cloud. It's like a data center that you can have your resources in it. And it says you can launch your resources like your virtual, you can define your virtual network, and you have full complete control over your virtual networking environment inside a VPC. So consider VPC as a data center for you. So you can have your own IP address range, and you can create your subnet in your configuration, and you can have your route table and your network gateways, all the network resources. Let's say you have a server room or you have a data center, so you have the network switches, you have firewalls, you have a boundary, right? You have physical access to your resources. This is the same idea. Actually, you have a data center, it's a virtual one, and you can start using it, and you can start managing your resources. You can create route tables and configure security mechanism for controlling ingress and egress traffic through your data center. So as you can see here, AWS says you can easily customize the network, and you can create a public facing subnet for your web servers that has access to the internet, and place your backend systems such as database or application servers in a private subnet with no internet access. This is actually a typical form of configuring the AWS, having one subnet accessible through the internet, so internet facing, and one private subnet, and you can put your web server, let's say, in the public subnet and the database server in the private, and then you can connect the public and private inside the AWS, and the end user can hit your public subnet from the internet. So I'm going to draw you a very nice diagram related to it, but for now this is just the VPC definition, and we can have multiple security mechanisms, you can see here, and there are benefits to it, like security, it's simple, and we have scalability and reliability on the AWS. There are multiple features related to the VPC connectivity. One of them that, for example, pretty normal in the VPC use cases is you have a direct connectivity to internet from a public subnets, and you can easily launch your resources with the internet access. Another thing is that you can have network address translation, or NAT. which it's gonna hide or mask your private IP addresses when you're accessing to the internet. So the NAT technology is also working, so you can have internet access with a NAT gateway. And another mechanism, which is we are going to practice it in this course, is you can connect securely your corporate data center or your on-prem data center or network to the VPC with a VPN, with the IPsec VPN, and technically you're extending your network to the cloud easily, which is pretty useful. Another feature in the VPC is VPC peer. This one means that if you have different VPCs in one AWS accounts, or even with multiple AWS accounts, you can connect these VPCs together and expand your network through them, which is pretty useful and pretty awesome. Another features with this VPC inside AWS is that we can have private connection between the AWS services and our VPC, and we don't need to go through the internet for accessing AWS services, which is pretty useful also. And other features, like we can have the AWS private link, which is the same thing. We have connections privately to our AWS services through SaaS solutions, and we can privately connect to different accounts and organizations through the backbone of the AWS, which is pretty useful. Going back to the console, as you can see here, this is the homepage for the VPC, and on the right side I can see the service health. If the right now I'm in the US West Oregon region, and you can see the Oregon is selected top here, and it says the service is healthy, and you can see a green check mark here. And at the moment that I'm talking to you, if I click on see all regions, so one of the interesting things related to this VPC homepage is, you know, this is a brand new account. This is completely new. I've just created this account. If I click on the VPCs and click on see all regions, you can see they're all one in all regions. This means that by default, AWS is going to create a VPC for my account in each of these regions. So we don't need to do anything. We have a VPC currently in place in all the regions inside AWS. And I've chosen Oregon right now, and I'm in US West. So, and it seems that I have a VPC, so it's pretty good, and I can start using this one. This page is pretty useful because you can see by default in AWS accounts, when you're creating an AWS account, you have some resources by default, like you have a VPC in each regions. Another one is if I go to a subnet and I open this one, you can see that there are some subnets by default in each region, right? So right now in Oregon there are 3 subnets, so which is pretty good. So by default right now we know that we have VPC, we have a bunch of subnets. Route table, if I click on this one, for each region we also have one route table. We have one-to-one mapping between route tables and VPCs then. And if I go down to network access lists, if I open this one, also you can see we have one network access list in each region. Same idea. So we have VPC by default, we have subnets for VPCs, and we have route tables for each VPC in each region, and we have network access list for them. And another one is security group. By default we have one security group for each region, which is pretty useful. It means that we can start working on our AWS. You don't need to create anything actually. In this lecture today, I'm not going to do anything in this dashboard. I'm just showing you that we have everything in place by default, and we can start using the default AWS account and AWS resources to go through the compute and start spinning up our virtual machines or instances. But later I will come back to this dashboard and start creating manual VPCs, manual subnets, route table, and other stuff to create a customized subnet for ourselves. Anyway, so if I go to the VPC, if I click here on my VPC, you can see I'm now in your VPC's page, and I have one VPC right now. You can see the ID, the state is available, and the IP address side there is 172.1.100/16, and I have the ACP option set, and I have assigned one route table to this VPC and also one network access list to this one. The tenancy is default, and this is a default VPC. So even you can click here and you can give it a name. You can say this is a default VPC in order to, I mean, it's easier later. We can easily find this one, although there's a default VPC yes here, but if you change this one to the default VPC, that would be better. If I click on the subnets on the left side, now I can see the subnets. It's the same idea. If you go back to the VPC dashboard here, if you click on the subnets here, you will go to this page. And as you can see in the Oregon, which is the US West 2, I have 3 subnets. Right now I have one VPC, which is a small data center virtual data center inside the AWS, and in this VPC I have 3 subnets by default, and these are the subnet IDs, and you can see the CIDR ranges and the available IP addresses. And US West 2A, C, and B, these are the availability zones. So as you can see here, for each availability zone I have a separate subnet. They're having their own route table, which is the same thing. It's the same route table. We have the network access list. Again, it's the same network access list for all of them. And default subnet and auto assign public IP addresses, yes, and auto assign IPv6 addresses, no. So as you can see here, for each availability zone, we have a separate subnet, but we can have a route table for all of the availability zones and subnets, and we can have a network access list for all of them. So this shows that route table and network access lists are separate from the subnets and availability zones, and these are resources that you are creating above the subnets and above the availability zones. I'll show you in a couple of minutes, but this is the console that you can select. I'm going to change these names also to default. That would be better for us. Default subnet, and I put the US West. This one is 2A. I'm going to copy this one and paste it here in US West 2C, and this one also here in 2B. So now I know that these are the default, although you can easily figure out, but I would like to give them a name, a proper name, so it's easier for me to understand. So another thing I want to show you is the route tables down here. If I click this one, it's the same idea again. You can go to the dashboard and come back here. Again, we have a default route table for our default VPC. So as you can see, because I've named it default VPC, now we can see it. So we have one route table by default, and it is technically assigned to the default VPC. I'm going to give this one a name also. So this is going to be default route table. If I go down here, you can see there is something like a properties of this object, this resource down here. So we have the summary, so we have the route table, this is the ID, and this is the name that I've just given it, an associated subnet to it. It's 0 subnet right now, and the VPC. If I go to the routes, you can see that one of the destinations is just the CIDR range of the VPC, and another one is just the default route to 0.0.0.0, and it is going to a target which is IGW, which is an internet gateway. So as we know, by default, when we are working in a default VPC, we have public internet access. So that's why the reason that we have internet access is that we have a default route to an internet gateway by default, and it's active. So that's why we can hit the internet. If I take a look at the subnet associations here, this is the default route, and it says you do not have any subnet associations, but the following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So don't forget this. This is pretty important. By default, any subnets that you have, it is going to associate with the default route inside your VPC. So it means that they have internet access right now, although they're not associated with anything, but by default they are associated with the default route and with the main route table, and they have internet access. So this is one thing that you have to always remember, and you have to create. I believe that you have to create your customized VPC subnets and route table and internet gateway and start configuring your resources inside your VPC. Do not use the default one, because there are some default configuration for them which they may be a problem for the security. It's not really safe all the time to use them. So my suggestion is to create your own VPC. Anyway, so I'm going to show you one last thing, and it's internet gateways here. If I click on internet gateways, you can see we have one internet gateway by default, which is it is already attached to this default VPC that we have by default. So I'm going to name this one also same thing, default internet gateway. So if I go back to the dashboard, I went through the VPCs, subnets, route table, internet gateway. The remaining part is network access and security groups. Let's take a look at the network access list also. So we have a default one which is associated with the default VPC and our subnets also. So I'm going to give it this one a name also. It's going to be default network access list. NACL. One thing that I want to emphasize here and I want to show you is that we have inbound rules and outbound rules, right? This is a network access list. So if I take a look at the inbound rules, by default it's allow all traffic. There's no, I mean, there's a deny, but there's an allow all at the top of this rule. It means it's wide open by default. Inbound rules and outbound rules, both of them, they're wide open. So don't forget this. These are all subnets that by default AWS created for us, but you have to know that by default you have a VPC which has a route table to access to the internet wide open, because there's no nothing inside the network access list. This is one thing that you have to always remember. And if I go to security groups, you can see that by default also there's a security group assigned to associated with my default VPC. And I'm going to give this one also the name like default security group. And there are inbound rules and outbound rules here. If I click on this one, it says all traffic, it's allow from the source, which is the this one. I mean, this is a security group. And outbound rules, it's the same idea. It's to destination 000. It means all traffic it's allowed to go out. So if I take a look at the inbound rules and outbound rules here, it means that they're all wide open. So this means that we can easily spin up resources inside the VPC. We can have internet access, and we need technically to prevent the access to the instances directly by a security group, which we can assign it directly to the resource like EC2 or other resources. So here, if I go back to the dashboard, then everything is wide open and we have all of our resources ready to use. So as you can see top here, we have a launch VPC wizard, and we can create all of these resources manually. For now, for the purpose of demonstration, I'm not going to create anything here, and I am just going to show you a diagram about how the VPC subnets, route table, internet gateway, network access, and security groups is working together in a big picture. And then I will move forward to the compute part and start spinning up virtual machines or EC2 instances in the AWS. And then after a while, when we go through the course more and more, and when we understand the services and features inside AWS more and more, then we will come back here and start working with all of these features here. Even down here, the VPN connection, and we can extend our VPC to on-prem data center, and I'm going to connect my on-prem servers to the AWS, and we will see that we can easily see each other and communicate with each other. So let's then go to a diagram. So I have this diagram here. Let's take a look at this one together. So as you can see, this is the AWS, and this boundary here, this is the AWS, and inside the AWS we have our own VPC. So the second boundary here, this one is our VPC. It's our virtual private cloud inside the AWS services. So it's like a data center. It's like a virtual data center that we can do whatever we'd like inside the VPC. Then inside the VPC, we have, I mean, for our VPC, technically we have a CIDR range. In this case, in this example, we have 172.30.100/16. This is our CIDR range for the whole VPC. And then inside the VPC, in this picture, in this example, we've created two different subnets. Subnet 1, which the IP address range or site is 172.31.00/20, and this one is 172.31.16/20. So there are two different ranges. The subnets are different. So we've created two subnets, one here and the other one here. So we have two different subnets inside our VPC. And as you can see, each subnet is in separate availability zone. And this one is in availability zone A, and this one is in availability zone B. And you have to know that subnets, they are restricted to each availability zones. you cannot have one subnet across two or more availability zones. Each subnet are inside one availability zone. So that's why we have subnet 1 in zone A and subnet 2 in zone B. In here, as you can see, we have a router inside the VPC. This is inside the VPC, but outside the subnets, right? And the route table here, the main route table, is also, it is connected to both of them, and it is something above the subnets. The route table is inside the VPC, and it shows that 172.30.100, which is the VPC CIDR, it's the local target, and the 000, which is the default route going to Internet Gateway. And this is the Internet Gateway. Internet Gateway is technically connected to your VPC, and it's one of the AWS resources. We can't have that much access over it. It's just provided by the AWS, and we can attach our VPC to it and connect to the internet. And we can have just one internet gateway for our VPC. So you can see in this diagram, when we are going to implement our VPC, then we have to identify, or we have to tell the AWS that this is our CIDR range. Then we have to create different subnets inside our VPC within different availability zones with different ranges, and then we have to configure a route table for these guys and or connection to the internet through the internet gateway. And then you can run your resources, your virtual machines, let's say, inside each subnet. And I have one EC2 instance here and one EC2 instance here, and then they can have internet access if this subnet is internet accessible. There's another thing here that we can add, which is the security group. And as you remember in the AWS console here, actually we have a security group assigned to the VPC here, and I would like to tell you that we can have security group also assigned to each EC2 instances, so we can control who can access from which IP address, technically which protocol people can access to our instances. So this is one diagram. There are multiple other diagrams out there, but I would like to share this one with you. So another thing that I would like to emphasize in this page is, so as I said before, we can have a security group somewhere here. Let's say I have a security group here, which is technically controlling access to the VPC, and then we can have security groups to control who can access our instances. So let's say when a traffic comes through from the internet to the AWS resources to the VPC, then it's going to hit the security group for the VPC first, and then after going through the route table, or based on the situation that we have, it's going to hit to the security group on each instances that we are running inside the AWS VPC and subnets. So this is it. This was just an overall overview of the VPC, and I will see you in the next lecture, which would be about the compute and how we can spin up an instance, EC2 instance, or subnet. But before moving forward, I would like to highlight again that we are not going to do anything, and we are just using the default configuration in AWS, and you'll see how easy it would be to run EC2 instances in a default configuration. Okay, thank you very much, and we'll see you in the next one.